In this video, we will solve a problem on income determination model with lump sum tax. The question is, use a graph to show how the addition of lump sum tax influences the parameters of the following income determination model. Graph the two results individually. So we have the income determination model as y is equal to c plus I. Y is our GDP or output, which is equal to consumption plus investment. Okay, consumption expenditure plus investment expenditure. Consumption function is 100 plus 0.6y. 100 is our autonomous consumption. They does not depend upon the level of income. 0.6 is our marginal propensity to consume. And investment is autonomous here, which is 40. Okay, in another situation, we have the same consumption function, but in this case, we have to incorporate the lump sum tax. So our disposable income will be equal to our total income minus the tax. And since tax is here lump sum, by lump sum we mean a tax independent of income. So tax is equal to 50 here. We need to graph this result. Okay, so I have written here our aggregate demand should be equal to consumption expenditure plus investment expenditure. First thing is, if I draw the graph on the horizontal axis, we measure the real GDP or output, and on this axis we measure the aggregate expenditure. That means consumption expenditure, investment expenditure. These are being measured on the vertical axis, and on the horizontal axis we measure the output. We draw a 45-degree line. This 45-degree line shows all the points where our aggregate expenditure is equal to our output or GDP. Okay, so any point on this 45-degree line will be a point where our output is equal to aggregate expenditure. The intersection of the aggregate expenditure line, okay, let us say I will show it here. So this is our aggregate demand, which is our aggregate expenditure also. The intersection of aggregate expenditure line and 45-degree line will be in equilibrium. Okay, this aggregate expenditure schedule shows how our total spending or aggregate expenditure increases as our output or real GDP increases. Okay, so our aggregate demand will be equal to consumption plus investment. Consumption function is given as 100 plus 0.6y plus 40. So in this case we don't have the lump sum tax, so 100 plus 40 will be equal to 140 plus 0.6y. So the intercept of this aggregate expenditure will be 140. Okay, and this is actually our consumption plus investment. Okay, aggregate expenditure, it intersects this 45-degree line here. That means this will be also our equilibrium. Okay, so what will be our equilibrium? So aggregate demand will be equal to y is equal to this. That means y minus 0.6, y will be equal to 140. So this is 0.4, y will be equal to 140. So 0.4 is actually 4 upon 10. So I can write y is equal to 140 into 4 upon 10 is 10 upon 4. Okay, so this is 2 2s are 4, 2 5s are 10. So again 2 7s are 40. So 7 5s are 35. That means our equilibrium level of income will be 350 at this point. Okay, so equilibrium occurs where our aggregate expenditure line intersects this 45-degree line. That means where our aggregate expenditure is equal to output. Now what happens when we incorporate the lump sum tax? So again our aggregate demand will be equal to consumption expenditure plus investment expenditure. So consumption function is being given 100 plus 0.6. Here we have the disposable income. Okay, so y subscript d, we have the disposable income plus 40. So 100 plus 0.6. Now this y subscript d is equal to y minus t. Okay, disposable income is the income which is left after the tax is being paid, and tax is here autonomous. So in place of y subscript to d, we have written y minus t. So the value of t is 50, so y minus 50 plus 40, so we have 100 plus 0.6 y minus 0.6 into 50 is 30 plus 40. Okay, so we have 140 minus 30, which comes out to be 110 plus 0.6 y. That means our new aggregate expenditure will look like this. We have this time, you can see the intercept is only 110. So let's draw it, but it is parallel to the earlier aggregate expenditure schedule. Why? Because we have the same slope as 0.6 here. Here we have also same slope 0.6, so only the intercept has decreased here. So let's draw it like this. Okay, let us say this is our C dash plus I dash. Okay, new aggregate expenditure. Again, equilibrium will occur where our aggregate expenditure schedule intersects the 45-degree line. So at this point, okay, and what will be the equilibrium here? That means our y should be equal to 110 plus 0.6 y. Okay, so when our output is equal to aggregate expenditure, so y is our output, or GDP should be equal to aggregate expenditure. Let us solve it for y again. So we have y minus 0.6 y, again 0.4 y should be equal to 110, or y is equal to 110 into, when I transpose it, it will become 4 upon 10. Transposing it will become 10 upon 4. So we have 2 2s are 4, 2 5s are 10. So we have 2 5s are 10. We are left with 1. So again 2 5s are 10. So 5 5s are 25. 5 5s are 25. 265. Sorry. 5 5s are 25, 5 5s are 25, 26, 27. Okay, so we got 275. So at this point we got 275 as new equilibrium. Okay, so here we have the intercept is 110. Now what has happened? Okay, you can see here a lump sum tax has a negative effect on the vertical intercept, because originally our intercept was 140, it has decreased to 110. That means we have minus 30 decrease in the intercept of aggregate expenditure. That means this lump sum tax has a negative effect on the vertical intercept of the aggregate demand function, which is equal to MPC times the tax. Okay, here we have seen it is this is our MPC times the tax rate. So this comes out to be 0.6 into 50 comes out to be 30. Okay, the slope is not affected. As I have told you, we can see these are the parallel lines, because the slope is same. 0.6 is here, again we have 0.6 here. Okay, also we have seen here income has fallen from 350 to 275 as a result of the lump sum tax. Okay, I hope I make myself clear in this video. Thank you.